Hello everyone. We have a question which says that coplanar forces of magnitude 40 Newton, 32 Newton, P Newton and 17 Newton act at a point. So first of all, we should understand what does the word coplanar forces means. Coplanar forces are the forces which are acting at a single point, and if we look at the diagram, this 70 Newton force, the 40 Newton force, 32 Newton and P Newton all are acting at this particular point. So therefore, all these four forces are coplanar forces. According to the question, these four forces act at a point in the direction shown in the diagram. Very clear, we can see that the system is in equilibrium. The condition that they have given us is an equilibrium condition. Find the value of P and theta. So P is basically an unknown force and theta is the angle. We have to find the value of this P and theta. Because the condition is an equilibrium condition, so definitely we have to work based on opposite forces are equal, but before that we should understand the components. Most of the students, I have seen that they have a misconception that the horizontal component is always a cos component. It is not like that. If the angle over here is whatever the angle, whether it is theta, alpha, beta, whatever it is, the side next to that angle would be a cos component side of this particular force, and the opposite side would be a sine component force. But for example, if this is an angle theta, that means then the side next to this angle would be a cos component of this particular force, and the opposite side would be a sine component of that particular force. So basically it depends upon the angle, and based on that we could easily find the component, whether it is a cos component or sine component. So the question that they have given us is that we have four forces. We have to find the value of P, and this theta condition given is an equilibrium condition. So we would split up the forces into horizontal and vertical. So by splitting up the horizontal and vertical forces, I have done over here, as you can see, 32 Newton and with a 20 degree. So the cos component would be 32 cos 20 over here, and the vertical side would be 32 sine 30 because this angle is with this side. So definitely that would be a cos component. 40 Newton is purely a vertical component, so no horizontal component for this one. For this 17 Newton, as you can see over there, this 55 degree is with this side, so definitely this side would be a cos component side, as you can see, 17 cos 55 degree for this one. And definitely if we talk about the horizontal force of this particular 17, that would be sine component, and 17 sine 55 I have written over here. Similarly, P Newton, and this angle is with the x-axis, so definitely that would be a cos component. So P cos theta over here, and downward it would be P sin theta. So I have splitted up all the horizontal forces and all the vertical forces. The condition is an equilibrium condition, so we could simply go on with the process of that the opposite forces are equal for both horizontal and vertical. So let us start with horizontal forces. So we have over here 17 sine 55 plus P cos theta, because both are pointing in this direction. So the sum of these two, 17 sine 55 plus P cos theta, would be equal to 32 cos 20, because it is in the opposite direction, because it is an equilibrium. So we have an equal sign. By simplifying this 17 cos sine 55 and simplifying 32 cos 20 and then rearranging it, we can say that P cos theta, which is over here, is equal to 16.14 by moving this on the other side and subtracting it and then simplifying it, equation 1. By looking at the vertical forces, we can see that two forces are pointing upward and two forces are pointing downwards. That means the sum of these two would be equal to the sum of these two, and I have written the same over here, that P sin theta plus 32 sin 20. So P sin theta plus 32 sin 20 would be equal to, because it is an equilibrium, 17 cos 55, which is at the top, plus 40, and after simplifying it, moving this 32 sin 20 on that side, adding these two, subtracting this one, and after simplifying it, we can say that p sin theta is equal to 38.8. So equation 2. Our target is to find the value of p and theta. So we have two different methods by which we could easily find the answer. First method is by dividing equation 2 by 1, that means dividing p sin theta divided by p cos theta. Over here, that means 38.8 divided by 16.14, cancelling the p sin upon cos is tan. 38.8 divided by 16.14 is 2.14, taking the tan inverse of 2.14, and we have the angle theta 67.4, which was asked us in the question. Now placing this value of theta in any of the equation, whether it is equation 1 or equation 2, for example, if we take equation 1, p cos theta is equals to 16.14, placing this value of theta over here and then dividing by 16.14, we get the value of p as 42 Newton, which was definitely asked in the question. So a very easy method. We do have another method also, that is also the easiest method, that is by squaring and adding equation 1 and 2. So that means if we square and add equation 1 and 2, means p cos theta with a square plus p sin theta with a square, squaring and then adding, and definitely 16.14, which is over here, and 38.8, which is over here, squaring and adding. After squaring and adding, we have 1765.9 over here. If we just simplify the bracket, p square cos square theta plus p square sin square theta, taking p square as common in the bracket, we are left with cos square theta plus sin square theta, and according to the identity, cos square theta plus sin square theta is 1. So we are just left with p square is equals to 1765.9 from here, taking the square root, and we have the same answer which we got from here. You can use any of the equation 1 or 2, and place this value of p over here. If we take equation 1, just place the value of p over here as 42, divide it by 16.14, divide by the value of p, which is 42, and then taking the cos inverse, we have the same answer, the same angle which we found from the method 1.